In this lesson for geography, we will look at how the earth was made. Stay tuned. How the earth was made. Approximately 4.6 billion years ago, the solar system was a cloud of dust and gas known as solar nebula. Gravity collapsed the material in on itself and it began to spin, forming the sun in the center of the nebula. With the rise of the sun, the remaining material began to clump up. Small particles drew together, bound by the force of gravity into larger particles. So the small fragments were bound together by gravity. So this gravitational pull held them together. The solar wind swept away lighter elements such as hydrogen and helium from closer regions, leaving only heavy, rocky materials to create smaller terrestrial worlds like Earth. So hydrogen and helium are two gas. So the wind blew those away. The solar wind blew them away. And the denser, heavier, rocky material, which couldn't be picked up by the solar wind, were left, and they formed the terrestrial world, which is known as Earth and Mars and so forth. But farther away, the solar winds had less impact on lighter elements, allowing them to coalesce into gas giants. In this way, asteroids, comets, planets, and moons were created. So you find those planets such as Jupiter and Saturn are largely gas-like. So you find that planets closer to the Earth are more rock-like or terrestrial in nature. That's why we say Earth is close to Mars, and by that we can see Mars as a close distance to Earth through a telescope, but we can also inhabit Mars because they are basically made up of the same material. Now, the planets that are further away from Earth, such as Jupiter and Saturn and so forth, they are mainly ghastly planets, and we can't really survive there as humans. Now, on Earth, we do have gas, we have oxygen, and we have carbon dioxide to begin with, but it is an amount that is sustainable to human beings. So now we continue. The Earth's rocky core first formed, with heavy elements colliding and binding together. The Earth's core is mainly metallic, as you will see in our next lesson, and based on the core, we have the other layers forming. The dense material sank to the center while the lighter material created the crust. And in our next lesson, you will learn about the Earth's crust, which is the first layer of the Earth. The planet's magnetic field probably formed around this time. So you find that towards the center of the Earth there is magnetic force fields and pulls that pulls huge objects, even in objects in the sky, down. And this is where the whole conspiracy of the Bermuda Triangle happened. We say that, there's a black hole there and anything past above or on the Bermuda Triangle tend to sink. Not so. Anything that passed of metal aspect over the Bermuda Triangle, such as a plane or a ship, it tends to get pulled into the magnetic force field. And they tend to show up at a later date at some other part of the Earth. The planet's magnetic field probably formed around this time. Gravity captured some of the gases that made up the planet's early atmosphere. So when we talk about the magnetic pull and the gravitational force field, we talk about Earth as it was 4.6 billion years ago. So now you can watch this very short clip taken from NASA about how the Earth was made. I hope you find this acceptable. I hope you understand this. We will also go through the processes in which the Earth was made in our first Zoom session, which will take place soon. There's also theories and conspiracies along how the Earth was made, such as the Big Bang Theory, and all these are theory, hence we're not sure about it. It's yet to be tested true. But the fact that this this whole idea that we're speaking of here could be close to and related to the Big Bang, but this is the first foremost thing that is accepted as to how the Earth was made 4.6 billion years ago. So now have a look at the video tutorial, but before you do that, I hope that you pause and take the relevant notes from this slide.
This is the story of our Earth's formation 4.5 billion years ago, and of a little asteroid called Bennu, who's also survived until now. We have the team at NASA to thank for bringing us this video.
The Milky Way, home to billions of stars, rising and setting over billions of worlds, including our own. In this vast expanse, how did our sun, the Earth, and the planets come to be? In recent decades, our understanding of the solar system's evolution has greatly improved, but deep questions remain. To answer those questions, astronomers are preparing to visit someplace very small. Asteroid Bennu. A lump of rock and organic material, the early building blocks of the solar system, of Earth, of us. Bennu is a time capsule, and its journey takes us way, way back, 4.5 billion years. The raw ingredients of Bennu and our solar system originated in a stellar nursery, a vast cloud of hydrogen, helium, and dust. Our own sun doesn't yet exist. Nearby are hot stars like this one, quickly burning up its fuel and destroying itself in a colossal explosion called a supernova. The explosion destabilizes our cloud, causing it to collapse. In the geologic blink of an eye, 100,000 years, gravity and angular momentum flatten the cloud into a swirling disk. In the center, where molecules crash together tightest, a protostar revs up to incredible pressures and temperatures. Deep within the disk, clumps of dust not much larger than a grain of wheat are flash heated into droplets of molten rock, called chondrules. The source of this heat remains a mystery. Chondrules are destined to become the building blocks of the solar system. Coaxed by gravity and turbulence, the chondrules clump. They grow into the first asteroids, into mountains, into planets. The asteroids are rubble piles of rock, metal, ice, and organics. This large asteroid is the parent body of Bennu, a protoplanet whose size we can only guess. Closer to the protostar, a planet begins to form. And then, dawn in the solar system. The protostar undergoes fusion and ignites, revealing our sun. But the solar system is far from finished. Jupiter most likely forms near its outer edge, but just 500 million years after the sun ignites, some believe that it slowly moves inward. Its massive gravity ripples the asteroid belt, disrupting countless asteroids and comets, flinging them toward the sun. They rain down on the inner planets, hammering and remelting large portions of their crust. Did these impacts also deliver organics and water, key ingredients for life? Back in the asteroid belt, Bennu's parent body is lucky. It survives this period of heavy bombardment. The solar system cools and calms. Jupiter and its many moons assume the orbits that we see today. Billions of years of quiet follow, more or less. Then 1 billion years ago, one theory suggests a collision shatters the protoplanet. Some of the debris loosely coalesces into a new, smaller body, Bennu. But Bennu will not stay in place. Dull, non-reflective, it slowly migrates toward the sun. Solar heating turns its warm side into a low-intensity thruster. Through millions of years, Bennu's orbit gradually tightens until it interacts with Saturn's gravity, altering its trajectory and hurling it into the inner solar system. Close encounters with Earth and Venus follow. Their gravitational tugs may have repeatedly stretched and reformed Bennu, turning it inside out and pulling off loose material. As a result, it has no satellites of its own, until now. Today, NASA is sending a spacecraft called Osiris-Rex to explore Bennu and retrieve a sample. Why? Bennu has survived its long journey and settled into a near-Earth orbit, bringing its secrets within our reach. Now it is ready to teach us more about the solar system's history, its formation, its evolution, and our own place among the stars.